Today we'll be working on lesson 510, which is word problem application. And here this is how you can use rational functions to do word problems. Now this lesson needs a very good understanding on lesson 5.8, which is how to solve rational applications or rational equations. So you need to go back and watch that video and make sure that you understand it to be able to solve the equations. But so today in this video I'm going to be focusing on how you can read the word problem, how you can set up your equation, but in order to solve the equation, which is your next step, you have to understand 5.8 very well. So again, this lesson is going to be how to set up your word problem. So let's read this. Curly can complete a job in 4 hours. So this is the first person, and he can do or she can do the work in 4 hours. Mo can complete the same job in 3 hours. So this is the second person, and this is his time. Working together, how long will it take them to complete the job? So basically what they're asking me is to find the time that they need to complete the job together. So let X be the time they need to finish the work together. There's 2 ways to do this problem, so I'm going to start with the first method, which is on your, method 1. That is on your paper. Method 1, basically, it's 1 over. Method 1 is that basically 1 over the first person time, or the time that it takes the first person to do it, plus 1 over the time it takes the second person to do it, which is equal to 1 over the time that they've taken to do this work together. So 1 over the first time, which is 4 hours, plus 1 over the second time, which is the second person, should equal to 1 over the time that they have taken together, and in this case it's X. So this is how you set up your equation. Now this, how to solve it, this is lesson 5.8. Now there's another way to do that. So this is going to be method 2. You can choose any method that you like, and they're both the same thing. Basically, the rule says the time that they take together over the time that one person can take to do the job, plus the time that they take together to do the job, over the time that the second person take to finish the job, should equal to 1, because this person and this person are doing one job. So let's see how we can apply this. Now, the time together is X, I don't know it, over the first person take 4 hours to do the job, plus the time together, which is X, we don't know it, this is what they need, over the time that the second person needs to take to finish the job, which is 3 hours. Together, it will be equal to 1. Again, you have to be able to solve this equation. I'm going to review the steps that you need to solve the equation. Number 1, you need to factor the denominator if you can. In this case, there's no factoring. Number 2 is to find the LCD. In this case, the LCD is 12x. Third step is you need to multiply by what's missing. So once you decide that the LCD is 12x, you need to multiply the top by what's missing. And number 4 is to cancel out the denominator and then solve for x. The same thing over here. So please go ahead and do the work. Now there is another problem on this sheet that's similar to this. I want you to go ahead and try it on your own. It's example 4, and then play the video again to check your work. So now I'm going to continue with example 2. If you want, you can go ahead and check how I did example 4 later on. Now example 2. Let's read that. a motorboat heads upstream a distance of 24 miles. And the current of the river is 3 miles per hour. So let's underline the words that are important. So the motorboat, first of all, is going upstream. It means against the current. And the distance to go upstream is 24 miles. The river is running at 3 miles per hour. The trip up and back takes 6 hours. Assuming that the motorboat maintained a constant speed relative to the water, what was its speed? So they're asking for the speed of the boat. So x is the speed of the boat. Let's read this again and make sure that we understand it. Assume that the water boat maintains a constant speed. What was its speed? So they want the speed of the boat. Now, every time you read speed and distance and time, you have to think of the rule distance equals the rate or the speed times time. Now, most of the time, or in this problem, we can rearrange this in order to find time. So if we divide by r, you're going to see that time is equal to distance over speed. So this is going to be the equation that we're going to be using here. Time equals distance divided by speed. Now, every time you want to do something like this, it's very important to set up like a table for yourself to help you solve the problem. Now, the distance, that he's going up and then back. So we're going to assume that A is going upstream and B is going to be like downstream because he's going up the river and down the river. So upstream is going to be A, downstream is going to be B. Now, going up the river, he's spending, like the distance is 24 miles. Going down is also the same distance, so also the distance is going to be 24. So in this table, the top is going to be the distance and the bottom of the fraction is going to be the speed, because distance over speed equals to time. So distance over speed should give me time. Okay, now the speed of this boat, because distance over speed, we want the speed. Now let's think of it. Let's say you are swimming and you're going upstream. Usually, are you going faster or slower? If you're going upstream, it means that the current of the river is not helping you, is like slowing you down. So remember, every time you go upstream, the river, the power of the river or the current is not helping you. It's obstructing you. So for example, if it usually takes you x, you have to subtract from x the speed of the river or the current. So as you can see, they told us that the current is running at 3 miles per hour. So if your speed is x, then your speed upstream is not going to be x anymore. It's going to be x minus 3. And that's the current, not helping you. Now remember, if you're going downstream, then basically your speed is x. But think of it, when you're going downstream, you're basically being carried by the current. So in this case, the river is helping you, so you're going faster. So it's going to be plus 3. So remember, upstream, it means like it's harder to swim. You have to put more effort. Your speed is going to go down because the current is like not helping you. So it's x minus 3. That's going to be your speed upstream. When you're going downstream, then the river is basically carrying you, helping you. You're going to be faster. So your speed is going to be x plus 3. And where did I get the 3 from? It's the speed of the current. So over rate, so distance over rate, so the distance is 24. And if you're going upstream, then your speed is going to be x minus 3. B is downstream, so again, distance over time, distance over speed. Distance is 24 over x plus 3. So let's see. The time taken to go upstream is going to be distance over speed. So the distance is 24 over the speed upstream, which is x minus 3. And the trip downstream, again, is going to be distance. We're going to be covering the same distance over the time or the speed taken going downstream, so it's going to be x plus 3. And they told us that the whole trip took 6 hours. So up and down took 6 hours. That's why you add them, and together they're going to be 6. This is how you set up your equation. Again, in order to solve it, you have to be understanding lesson 5-8. Now, that's what I want to say about number 2. You can solve the equation on your own. Now let's move on to number 3. So now I'll be working on example 4. David and Laura can mow the lawn in 40 minutes. So together they can do it in 40 minutes if they work together. So let's write down the rule. Time together, I'm going to use the second method, but you can use any method that you like, the first or the second, over the time that David takes. So I'm going to write T David plus the time together over the time that Laura takes should be equal to 1. So the time together, this is going to be a 40. This is going to be a 40 minutes. Now, let's continue reading. If David works twice as fast as Laura, so you have to underline this and try to understand it. How long would it take David to mow the lawn? So we really don't know how long Laura takes. So we don't know how long David takes, but let's see. If Laura takes 20 minutes, just like an assumption, let's assume that she takes 20 minutes to finish the job. David works twice as fast as her. So if Laura takes 20 minutes to finish her job, David will do the work in 10 minutes. He's faster, so he will take less time. Now, what if she takes her, let's say, 40 minutes to do the work? Then it will take him 20 minutes to do the work. So he's faster, he takes less time. But we don't really know how long Laura takes, so I'm going to say, if David, let's say, take 10 minutes to finish the job, it will take Laura more because she's slower, so it will take her 20. So let's say that David is X because we don't know. So how long will it take Laura to finish it? It will take her 2x. Remember? You can always put in numbers to check that it makes sense or not. So again, if it takes Laura 40 minutes, it takes him half the time, which is 20. So if it takes him, let's say, 10 minutes, it takes her twice the time. That's why it's 2x. So let's rewrite it. 40 over the time it takes David to do the work, which is x, plus the time together, which is 40 over the time that Laura takes to finish the job, so that's 2x. And together, it's 1. So this is my second equation. 1 means 1 over 1. If you want to solve it, you find, again, the same concept, LCD, and so on. So again, I'm going to help you to set up, but I'm not going to solve. So the first 80 miles of a trip, Beth pickup truck traveled 10 miles per hour slower than it did for the remaining 50 miles. The total time was 3 hours. Find the speed of the truck on each part of the trip. Okay, so let's say that the speed of this truck is S. We don't know, so let it be S. If he's going S on the second trip, let's read again. So basically he's going 10 miles slower than it did for the remaining 50 miles. So think of it that you have a first part and you have a second part of the trip. Remember, time equals distance over speed. Okay. The distance he covered, so let's think of the beginning. So beginning, or the first part, the beginning, to begin. Time equals distance, which is 80 miles over speed. For the second part of the trip, time equals to distance, so 50 miles over the speed. Now, at the beginning, or at the first 8 miles, he's going 10 miles slower than the second part of the trip. So if he's going at a speed of s in the second part of the trip, then he's, remember he was driving slower, so it's going to be s minus 10 for the first. So if 10 miles slower, it means s minus 10. Probably he was driving and then he thought, oh my god, I have to pick up the speed to be able to be there on time, so he went faster. So the beginning distance was 80 over s minus 10 because he was going 10 miles slower. The second part of the trip, he was traveling 50 distance, and he was traveling s. Now, the whole trip took 3 hours. So the first time and the second time, if you add them together, it should equal to 3. So T1, or the first part of the trip, plus the second part of the trip should be equal to 3 hours. So 80 over s minus 10, which is the time he took to travel the first part, plus 50 over s, the time taken to travel the second part. Altogether, he spent 3 hours. This is how you set it up. You can put over 1, and you can use the 5/8 lesson to be able to solve for s, which is your speed. I hope this is helpful. We're going to go over this again in class. It's good to listen to this at first, and then ask me as many questions as you want tomorrow in class.